Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University School of Sciences, SOS. Bachelor of Science, Multidisciplinary, BSCM. Geography, BGGCT 131 Physical Geography. Block-1 Geo-tectonics. Unit 1 Origin of Earth, 1.1 Introduction. You might have studied the basics related to origin of the Earth in your school. And you have fairly good idea about it. In the very beginning unit of this course, we will further familiarize you with this theme in more detail. The academic inquisitiveness may make you think about many questions related with the origin of Earth. For example, how we can define the universe, what are its basic concepts and so on. In simpler ways, universe has been defined as the totality of existence. It means that the entire gamut of astronomical bodies, comprising planets, stars, galaxies, the contents of intergalactic space, the smallest subatomic particles, and all particles of matter and energy are included in the universe. Humans have always been eager to know more and more about it. You will study the basic concepts of the universe in the section 1.2. Various astronomical objects like stars, planets, etc., orbit the sun in a constant manner which we collectively know as solar system. It consists of 9 planets, some dwarf planet, 63 moons, millions of smaller astronomical bodies like asteroids and comets, and it also includes huge quantities of gas and dust particles. The planets along with their satellites revolve around the sun. It is the most important part of the universe and suitable environment for higher forms of life are found only in one of the inhabitable planet which is known as Earth. You will understand all about this solar system from section 1.3. You will also study the hypotheses related to the origin of Earth and the solar system from the section 1.4. Expected learning outcomes. After studying this unit, you should be able to explain the basic concepts of universe, define the solar system, explain various hypotheses related to the origin of Earth and the solar system. 1.2 Basic concepts. 1.2.1 Earth as a black body. Can you visualize that the Earth is much close to being a black body radiator? It means that a black body can absorb heat at any wavelength. But it also emits heat at a particular wave pattern. It is on account of the Earth's closeness to being a black body radiator which is responsible for the greenhouse effect, as it can absorb solar energy at any wavelength, mostly short wavelength, i.e. incoming terrestrial radiation, but emits it in a narrow band of radiation. Do you know how the evolution of various life forms became possible on the Earth? It is this greenhouse effect which makes life possible on Earth, otherwise the sun's radiation would also be radiated away. Though the Earth is close to being a black body radiator, but the energy absorbed by it is at different level, e.g. ultraviolet rays being absorbed by ozone layer. The Earth reflects about 1/3 of the energy reaching it, so it appears to be quite bright, but it is close to being a black body radiator. 1.2.2 Rotation and revolution of Earth, planets and satellites. You all are familiar that Earth's rotation is the rotation of the solid Earth around its own axis. The Earth rotates from west to east. As viewed from the north star or pole star, the Earth turns anti-clockwise. The Earth's axis of rotation meets its surface at the North Pole, in the northern hemisphere. The South Pole is the other point where the axis of rotation intersects its surface, in Antarctica. The Earth rotates once in every 24 hours with respect to the Sun and once every 23 hours 56 minutes and 4 seconds with respect to the stars. Earth's rotation is slightly slowing with time, thus the day was shorter in the past. This is due to the tidal effect of the moon has on the Earth's rotation. Atomic clocks show that a modern day is longer by about 1.7 milliseconds than a century ago, slowly increasing the rate at which UTC is adjusted by leap seconds. You know that the rotation of the Earth is responsible for the alternate periods of light and darkness that gives us day and night, while the Earth's revolution is the complete orbit of the Sun by the Earth. This is called a year and takes 365.25 days to complete one orbit. The path of this revolution, the Earth's orbit, is an ellipse rather than a circle. The Earth is consequently nearer to the Sun in January than it is in July. The difference between its maximum and minimum distances from the Sun is 3 million miles. 4.8 million kilometers. This difference is not great enough to affect climate on the Earth. If you were to look down on the solar system from above, that is, so that the Sun is seen to rotate anti-clockwise, you would see Earth revolve around the Sun in anti-clockwise direction. It is also the direction in which both the Sun and the Earth rotates. Diagrammatic representation of major planets' alignment in the solar system is presented in Fig. 1.1. In fact, the planets rotate and most of the moons revolve around the planets in anti-clockwise direction. This common anti-clockwise direction of rotation, revolution very likely reflects the rotation of the original cloud from which all components of the solar system were formed. The period of revolution of the Earth around its orbit defines the year 1 of the planet's natural time scales. The mean Sun-Earth distance is 149.5 million kms. This defines the astronomical unit. Two key positions along the orbit are perihelion, the point of closest approach to the Sun. This occurs on the 3rd of January, when the Sun-Earth distance is approximately 146 million kilometers. Aphelion, the point at which Earth is farthest from the Sun. This occurs on the 4th of July, when Sun-Earth distance is approximately 156 million kilometers. The difference in distance between perihelion and aphelion, some 1 OMILLIONKILOMILLISECOND, is small but important. One consequence is that Northern Hemisphere winters, Southern Hemisphere summers tend to be milder than Southern Hemisphere winters, Northern Hemisphere summers. In part, this helps to explain the existence of the very large ice cap in the Southern Hemisphere polar region. The dates of perihelion and aphelion change slowly with time because the whole orbit rotates slowly anti-clockwise in the ecliptic plane, and the shape of the orbit, as expressed by the eccentricity, changes over time. Always keep in mind that the revolution of the Earth in its orbit around the Sun is independent of the rotation around its axis. You can visualize the cycle of day and night on Earth from Fig. 1.2. Fig. 1.2. Artistic impression of Earth's rotation. Look at the screen. How will you understand the change in seasons? The change in seasons is caused by the tilt of the Earth's axis to the plane of its orbit, making an angle of 66.5 degrees. When the northern end of the Earth's axis is tilted toward the Sun, the most direct rays of sunlight fall in the northern hemisphere. This causes its summer season. At the same time, the southern hemisphere experiences winter, since it is then receiving indirect rays. Halfway between, in spring and in autumn, there is a time, see equinox, when all parts of the Earth have equal day and night. When the northern end of the Earth's axis is tilted away from the Sun, the least direct sunlight falls on the northern hemisphere. This causes its winter season. 1.2.3 Universe and galaxies. Galaxies are sprawling space systems composed of dust and countless stars. The number of galaxies cannot be counted. The observable universe may alone contain 100 billion galaxies. Some of these are similar to our Milky Way, whereas others are quite different. The diameter of our galaxy, Milky Way, is about 100,000 light-years. It contains more than 1,000 million stars. Our Sun with its solar system is about 30,000 light-years away from the center of the Milky Way. Like other stars, the Sun with its solar system is revolving around the center of the Milky Way. The period of revolution is about 224 x 106 years. Sun has thus made only 2 complete rounds around the center of the Milky Way till now. The solar system revolves around the Milky Way with the speed of 285 km per second. Now we will discuss about various types of galaxies. Classifications of galaxies. It was astronomer Edwin Hubble who classified galaxies into 4 major types. These are known as spiral, barred spiral, elliptical and irregular galaxies. Most of the nearby bright galaxies are spirals, barred spirals or elliptical. Let us learn more about the same. Spiral galaxies have a bulge at the center and a flattened disk containing spiral arms. Spiral galaxies have a variety of shapes and are classified according to the size of the bulge and the tightness and appearance of the arms. The spiral arms, which wrap around the bulge, contain numerous young blue stars and lots of gas and dust. Stars in the bulge tend to be older and redder. Yellow stars like our Sun are found throughout the disk of a spiral galaxy. The disks of spiral galaxies rotate somewhat like a hurricane or a whirlpool. Barred spiral galaxies are spiral galaxies that have a bar-shaped collection of stars running across the center of the galaxy. Elliptical galaxies do not have a disk or arms. Instead, they are characterized by a smooth, oval-shaped appearance. Elliptical contains old stars and possess little gas or dust. They are classified by the shape of the ball, which can range from round to oval, baseball-shaped to football-shaped. In contrast to the disks of spirals, the stars in elliptical galaxies do not revolve all around the center in an organized way. The stars move on randomly oriented orbits within the galaxy, like a swarm of bees. Irregular galaxies are galaxies that are neither spiral nor elliptical. They tend to be smaller objects that are without definite shape, and tend to have very hot newer stars mixed in with lots of gases and dust particles. In this section, you have learnt about 4 types of galaxies along with their characteristic features differ in size. The planets located in the middle of the solar system are bigger in size than those on the sides. Geophysicists call this arrangement of planets as cigar-shaped. The planets of the solar system can be classified into 2 groups: inner or terrestrial planets and outer planets. Fig. 1.3. Look at the screen. Fig. 1.3. Artist's impression of the solar system showing the inner planets Mercury to Mars, and the outer planets Jupiter to Neptune, and beyond. Credit, NASA. Inner or terrestrial planets. The inner circle consists of 4 planets, including Mercury, Venus, Earth along with Mars and asteroids. These planets are called inner planets as they lie between the Sun and the belt of asteroids, and are closer to Sun. They are called terrestrial, which means Earth-like, as they are made up of rocks and metals. These planets are comparatively small in size and have relatively higher density. Their speed of rotation is less. They either have no satellite or very less satellites. For example, the Earth has only 1 and Mars have 2 satellites. The outer planets, they are also known as the giant planets or Jovian planets, Jupiter-like. The outer circle consists of 5 planets, namely Jupiter, Saturn, Uranus, Neptune and Pluto. These planets are bigger in size and are less dense. They have thick atmosphere mostly composed of helium and hydrogen. Their speed of rotation and number of satellites are more compared to the inner planets. The 4 smaller inner planets, Venus, Earth, Mars and Mercury, also called the terrestrial planets, are primarily composed of rock and metal. The 4 outer planets, called the gas giants, are substantially more massive than the terrestrials. The 2 largest, namely Jupiter and Saturn, are composed mainly of hydrogen and helium. The 2 outermost planets, Uranus and Neptune, are composed largely of substances with relatively high melting points, compared with hydrogen and helium, called ices, such as water, ammonia and methane, and are often referred to separately as ice giants. All planets have almost circular orbits that lie within a nearly flat disk called the ecliptic plane. The vast majority of the system's mass is in the Sun, with most of the remaining mass contained in Jupiter. The solar system also contains regions populated by smaller objects. The asteroid belt, which lies between Mars and Jupiter, mostly contains objects composed, like the terrestrial planets, of rock and metal. Beyond Neptune's orbit lie the Kuiper belt and scattered disk, linked populations of trans-Neptunian objects composed mostly of ices. Within these populations are several dozen to more than 10,000 objects that may be large enough to have been rounded by their own gravity. Such objects are referred to as dwarf planets. Identified dwarf planets include the asteroid Ceres and the trans-Neptunian objects Pluto and Eris. In addition to these 2 regions, various other small body populations, including comets, centaurs and interplanetary dust, freely travel between regions. 6 of the planets, at least 3 of the dwarf planets, and many of the smaller bodies are orbited by natural Satellites, usually termed moons after Earth's satellite moon. Each of the outer planets is encircled by planetary rings of dust and other small objects. The solar wind, a flow of plasma from the Sun, creates a bubble in the interstellar medium known as the heliosphere. It extends out to the edge of the scattered disk. The Oort cloud, which is believed to be the source for long-period comets, may also exist at a distance roughly 1,000 times further than the heliosphere. The heliopause is the point at which pressure from the solar wind is equal to the opposing pressure of interstellar wind. The solar system is located within one of the outer arms of the Milky Way, which contains about 200 billion stars. Before giving a vivid description about hypotheses related to the origin of Earth and solar system, it is of utmost importance to know some of the characteristics of the solar system, which are as follows. The axis of all these planets is tilted towards their orbital planes, but it is tilted differently by different planets. All the planets rotate around their axis, and the speed of rotation of these planets vary from each other. All these planets revolve around the Sun in anti-clockwise direction. The path of these planets is either circular or elliptical. All these planets are very small in size and mass when compared to the Sun. The Sun comprises about 98% of the solar system. The distribution of angular momentum in the solar system is of special type. According to the law of conservation of angular momentum, the total angular momentum of an isolated system remains constant. It means that if any body is rotating, the total amount of its angular momentum will always remain constant unless an external force is applied on the rotating body. Angular momentum is the product of the mass, angular velocity, and the square of the radius of the rotating body. The distribution of the angular momentum in the solar system is not same. It is very interesting to know when we compare the angular momentum of the Sun with the angular momentum of other planets, we can observe that the Sun contains only 1.7% of the total angular momentum, table 1.3.1. The remaining 98.3% of it constitutes the other planets of the solar system. Contrary to it, the Sun possesses 99.9% of the total mass of the solar system, whereas the planets contain only 0.1% of mass. Table 1.3.1 Angular momentum. Members of solar system angular momentum. Mercury 0.03, Venus 0.69, Earth 1.00, Mars 0.13, Jupiter 725.00, Saturn 294.00, Uranus 64.00, Neptune 95.00, Pluto 1.00, Sun 20.00. Sum of the solar system 1285. 1.3.3 Asteroids and planetoids. Asteroids are minor planets, especially those of the inner solar system. The larger ones are called planetoids. These terms have specifically been applied to any astronomical object orbiting the Sun that did not show the disk of a planet. There are millions of asteroids, many thought to be the shattered remnant of planetesimal bodies within the young Sun's nebula, which never grew large enough to become planets. The large majority of known asteroids lie in the belt between the orbits of the Mars and Jupiter. However, the other orbital families exist with significant population, including the near-Earth asteroids. Individual asteroids are classified by their characteristic spectra into three groups, namely C-type, carbon group, S-type, stony, and M-type. Metallic. Only one asteroid 4 Vesta, which has a relatively reflective surface, is normally visible to the naked eye only, but in very dark skies and when it is in favorable position. 1.4 Origin of Earth and Solar System. From time to time, various scientists have given their concepts, hypotheses, and theories in order to explain the origin and evolution of the solar system. Such views and concepts may be divided into two groups: religious concepts and scientific concepts. Religious concepts are discarded as they do not have logical and scientific base. The scientific concepts are generally based on hard sciences divided into two schools, namely hot origin concepts and cold origin concepts. According to hot origin concept, the planets are believed to have been formed from the matter which was either hot or was heated during the process of Origin of the planets. On the other hand, the school of the cold origin concept explains the solar system originated from the matter which was either initially cold or always remained cold, on the basis of the number of heavenly bodies involved in the origin of the solar system and the Earth. The scientific concepts are divided into three groups: monistic concept, one-star hypothesis; dualistic concept, binary hypothesis, i.e., involving two heavenly bodies; and modern concept. 1.4.1 Monistic concept. Monistic concept, one-star hypothesis. According to this hypothesis, the solar system originated from one star due to the gradual evolutionary process. The hypothesis of Kant, Laplace, Roche and Lockyer comes under this category. 1.4.1.1 Gaseous hypothesis of Kant. The German philosopher, Kant, put forward his hypothesis in 1755, claiming that his hypothesis was based on sound principles of Newton's first law of gravitation and rotatory motion. According to him, innumerable particles of primordial matter were scattered in the universe, and these particles started colliding against each other due to gravitational attraction. As a result of this collision, heat was generated. This changed the primordial matter from solid to liquid and from liquid to gaseous state. Thus the original cold and motionless cloud of matter became in due course a vast hot nebula and started rotating around its axis, and with continuous rise in the number of primordial particles, the nebula expanded in size. Due to the continuous increase in size of nebula, the speed of rotation became so fast that the centrifugal force exceeded the centripetal force. This created a bulge in the center of the gaseous mass. When this bulge increased in size, the rings started forming one by one and were separated from the middle part of the nebula and were thrown off due to centrifugal force. The residual central mass became the sun and rest of the rings became the planets. By the repetition of the same process, the rings were separated from the newly formed planets, and the material of each ring condensed to form satellites of the concerned planets. Critical analysis. 1. Kant has not explained the source of the primordial matter. 2. Kant said that the particles of the primordial matter started colliding due to gravitation energy. He has not explained how the source of energy which caused motion of these particles, which were cold and motionless in initial state, suddenly became active. 3. According to science of law of motion, the collision of the particles can never generate rotatory motion. 4. Kant's assumption that the speed of rotation of the nebula increased with the increase in the size of the gaseous matter is also against the law of science of law of motion. Fig. 1.4. The nebula hypothesis describes how the solar system formed from a cloud of gas and dust into a disk with the sun at the center. This painting was made by an artist. It's not an actual photograph of a protoplanetary disk. Look at the screen. Conclusion. Though in the beginning, Kant's hypothesis received appreciation on a large scale, but later it was disapproved as it was based on assumption and wrong application of Newton's law of gravitation and invalid concepts. But, then too, we cannot overlook the fact that it was the first scientific attempt ever made to solve the mystery of the origin of the Earth. 1.4.1.2 Nebula hypothesis of Laplace. Kant had postulated his hypothesis before Laplace therefore got the advantage of refining this hypothesis by removing the inherent weak points and inaccurate concepts of Kant's hypothesis. Thus, we may consider the hypothesis of Laplace as the modified version of Kant's hypothesis. Para. Laplace explained his concepts about the origin of solar system and the Earth in his book entitled Exposition of the World Systems in the year 1796. According to him, a huge and hot gaseous matter called nebula existed in the space which was continuously rotating on its axis. Fig. 1.4. This nebula was losing heat from its outer surface due to the process of radiation and was thus cooling and reducing in size and volume due to contraction on cooling. As the size and volume of the nebula decreased, the velocity of rotatory motion began to increase. It increased so much that the centrifugal force became greater than the centripetal force. A state came when the centrifugal and the gravitational pull became equal at the equatorial bulge, which made it weightless. As a result, the rings started detaching, i.e., separating from the equatorial bulge of the contracting nebula. The outer rings, layers, thus started separating from the nebula one by one. Each ring condensed at a point in the form of gaseous accumulation and started rotating around the nebula. This gaseous mass later cooled and formed as the planets. The remaining part of nebula thus became the Sun, and the 9 rings became the planets. The satellites were also formed by repetition of the aforesaid process. From this, we can conclude that Laplace considered that the solar system as well as the planets are all originated from the same source. This hypothesis is of great importance. The rings revolving around Saturn is an excellent example that supports the Laplace's hypothesis. Besides this, there are many nebulas existing in the universe which supports his view. When the diameter of the revolving mass reduces, its speed of rotation increases. This view of Laplace is in accordance with the laws of motion science. The presence of the same kind of elements in the formation of planets also proves his views right. According to Laplace, all planets have been formed due to cooling of the gaseous mass. The upper layer of this gaseous mass became solid, but the inner part is still in liquid state. The liquid lava erupting from the volcanoes supports his hypothesis. It is for this reason that this hypothesis commanded respect for more than 50 years. But as there are two sides of a coin, this hypothesis also has its demerits. Critical analysis. 1. Laplace assumed that there existed a hot rotating nebula in the space. But he did not explain the source of origin of nebula and the source from where it received heat and rotation. 2. Laplace did not explain why only 9 rings came out from the irregular ring detached from the nebula and why not more or less rings. 3. If the planets have been formed from the rotating nebula, then the part of the nebula, i.e. Sun, should rotate at the highest speed due to decrease in size, but it is not so. 4. Critics feel that if the Sun is the remaining part of the nebula, it should have a bulge in the middle, but it is not so. 5. According to Laplace's hypothesis, all satellites should revolve in the direction of their father planet, but it is not so, as planets like Saturn and Jupiter revolve in the opposite direction of their father planets. 6. If we accept Laplace's view that planets were formed from the nebula, then the planets would have been in liquid state in the initial state and hence would not have been able to rotate around the Sun. Only a solid matter can rotate or revolve along or near the circular path without losing its shape. 7. The British physicist James Clerk Maxwell and Sir James Jeans showed that the mass of the rings was not enough to provide the gravitational attraction to form individual planets. 8. According to S. W. Wooldridge and R. S. Morgan, the small degree of cohesion between the particles of nebula would make the formation of ring a continuous, not an intermittent process. 1.4.2 Dualistic concept. According to dualistic concept, binary hypothesis, the solar system originated from 2 stars. The hypothesis of James Jeans, Chamberlain and Moulton, Weizsäcker, and Russell comes under this category. 1.4.2.1 The planetesimal hypothesis of Chamberlain and Moulton. T.C. Chamberlain, a geologist, in collaboration with Forrest Ray Moulton, an astronomer, postulated a hypothesis known as planetesimal hypothesis. According to this hypothesis, the planets originated from planetesimals. They believed that 2 big stars, i.e. the Sun and a companion star, existed in the universe in the initial stage. The Sun was much bigger than the present Sun, and was made of very small particles which were cold and solid. The companion star was moving on its path, and while doing so, it came closer to the Sun, and due to the gravitational pull exerted by the star, solar tide accrued, and a large number of particles got detached from the outer layer of the Sun. They termed these particles as planetesimals. These planetesimals could not combine with the moving star because by the time they reached it, the star had moved ahead on its path and vanished in the space. These planetesimals were attracted by the proto-Sun and started revolving around the Sun. These planetesimals were of different sizes. The bigger planetesimals served as the nucleus and attracted the smaller planetesimals towards them. Gradually, the bigger planetesimals became bigger and became the present planets. Critical analysis. 1. Jeffrey has criticized this hypothesis, saying that such big planets cannot be formed by the material ejected from the Sun. 2. The assumption that the increase in the size of the nucleus due to collision of the planetesimals is not trustworthy. 1.4.2.2 Tidal hypothesis of James, Jeans and Jeffrey. It was Sir James who propounded the tidal hypothesis to explain the origin of the Earth in 1919. Later on, Harold Jeffrey made some suggestions by inclusion, of which the hypothesis became more relevant and significant. According to this hypothesis, the Sun existed as a big mass of gas rotating around its own axis in the universe. Besides the Sun, there existed one more star called The intruding star, which was many times bigger than the Sun. As this star neared the Sun, tides started occurring on the outer surface of The Sun due to gravitational pull exerted by this star. When this intruding star came at its closest point to the Sun, the height and the size of the tides increased. As a result, huge amount of matter was ejected from the Sun and a cigar-shaped tide filament which was thousands of kilometers in length was created. James Jeans named this ejected cigar-shaped matter a filament as it was thicker in the center and thinner at the ends. This filament got separated from the Sun and then came closer to the intruding star, but by then the star moved ahead on its path. Therefore, this filament could neither unite with the Sun nor with the star. This filament then started revolving the Sun due to the effect of gravitation. Due to the gravitational pull and condensation, knots started forming from the liquid matter of the filament. The knotted filament then condensed and formed different planets. Due to the tidal effect, the filament remained thicker in the center and thinner at the ends. Hence, the planets formed by this filament are bigger in the center and smaller at the sides. Characteristics of this hypothesis. 1. If we arrange all the planets in a line, we will see that the bigger planets lie in the center and the smaller at the end. This cigar-shaped arrangement supports his hypothesis. 2. The other characteristics of James' hypothesis, that the arrangement of the satellites too is cigar-shaped, again supports his hypothesis. 3. The smaller planets comparatively took less time to cool, hence these planets either have very less or no satellite at all. The bigger planets remained hot for a longer period, hence they have more satellites. 4. In this hypothesis, it was assumed that all planets originated from the separated filament of the Sun. All planets are made of the same matter, which again supports this hypothesis. 5. This hypothesis successfully justifies the fact that all the planets were formed at the same time. Critical analysis. 1. According to the critics like Delevan, in the distance between different stars in the universe is very big. Hence, there is a remote possibility of the star coming so close to the Sun that it can be affected by the gravitational force of the Sun. 2. According to Russell, there is no possibility that such a huge amount of material of filament could have come out of the Sun to form planets at such a greater distance. 3. Some scientists are of the view that planets cannot be formed due to the cooling of the gaseous filament. They instead feel that the gaseous filament might have disappeared in the universe due to the prevalence of extremely high temperature values. 4. Many astrophysicists are of the view that the angular momentum imparted by the star to the planet was not high enough to match the existing angular momentum of the planets of our solar system. 1.4.2.3 Binary star hypothesis of Russell. Russell was of the view that there were two stars near the primitive Sun. These are known as the companion star and the approaching star. The companion star was revolving around the Sun. Later on, the approaching star came near the companion star and it too started revolving. The direction of the star was opposite to that of the companion star. Russell assumed that there might have been a distance of 45 to 65 lakh kilometers between the stars. So, the approaching star might have been at a far greater distance from the Sun than the companion star. Hence, there would have been no effect of the tidal force of the approaching star on the Sun. But the companion star would have certainly been attracted toward the approaching star because of the massive gravitational force. As these two stars came closer, the gravitational and tidal force between them increased, which created a bulge on the outer surface of the companion star. When the approaching star came near the companion Star huge amount of matter was ejected from it due to the gravitational force exerted by the approaching star. The ejected matter started revolving in the direction of the approaching star, i.e., in the opposite direction of the revolution of the companion star. The planets were formed from this ejected matter of the companion star, and the satellites were formed from the ejected matter from the planets due to the mutual attraction. 1.4.3 Modern concept. 1.4.3.1 The Nova hypothesis of Hoyle and Littleton. The two mathematicians named F. Hoyle and Littleton of the Cambridge University presented their theory known as supernova hypothesis in the year 1946. Their hypothesis was based on nuclear physics. Energy which is emitted by any star in the form of light, heat, etc., is generated by the process known as nuclear fusion. According to them, the heavy elements played important part in the formation of planets. These heavy elements are formed when atoms of lighter elements combined under intense heat and pressure released vast amount of energy. These heavy elements constitute 90% of the total mass of the planets. The main constituent in the formation of the stars is hydrogen. The planets, on the other hand, have less than 1% hydrogen. The scientists F. Hoyle and Littleton showed that the heavy elements originate even due to the burning of hydrogen. But an ordinary star like Sun can only form an element like helium. The formation of the heavy elements is possible only if the burning of hydrogen takes place at high temperature. Such high temperature is available only in supernova stars. A star becomes supernova star when it is left with very less hydrogen, which is not enough to burn. Hydrogen is the source energy which gets converted into helium and generates energy. In the case of scarcity of hydrogen, the star has to shrink in order to produce energy. The speed of rotation of the star increases when it shrinks. The force at the center increases due to high rotational speed. As a result, the star throws out first the lighter matter and then the heavy elements. The formation of the heavy elements in the universe is possible in this state only. The cosmic light, which is many lakh times more than the light of sun, is visible in the center after the heavy metals are thrown at a distance. These stars with such huge light are termed as nova. According to these scientists, the planets have been formed due to the explosion of one supernova star. The explosion of the supernova star generated intense heat equivalent to 5x 10 to 9 degrees Celsius, which was sufficient enough to start the process of the nuclear fusion. According to them, the two stars present there were the Sun and the supernova star. The distance between these two stars was the same as the distance between the Sun and Jupiter. The explosion of the supernova generated intense heat and pressure from which the primitive Earth was made. Thus, the planets of our solar system were formed due to the condensation of the matter of the disk. Form of the matter thrown out of the matter by supernova due to its explosion. Critical analysis. 1. This hypothesis does not support the origin of the pair of stars. 2. It fails to explain the peculiar arrangement of the planets on the basis of their direction of rotation, their size, plane of revolution, path of the planets, and the lighter constituent elements of the planets of the outer circle of our solar system. 1.4.3.2 The Big Bang Hypothesis. This theory was postulated by Lemaitre in 1950-60 and validated in 1972. According to this theory, all matter in the universe existed in the form of dense and huge primordial matter. As violent explosion took place in this primordial matter, as a result of which the dust particles present in this matter were scattered in the universe and formed the present universe. Based on the new facts of evolution progression of Hoyle also theorized the origin of the universe. Two Indian scientists, namely Govind Swarup and Vijay Kapahi of Tata Institute of Fundamental Research, TIFR, are also working on this principle of Big Bang theory. In their view, the universe originated about 20 billion years ago from the explosion of the big ball of fire which has been formed by the ejected matter of primordial matter. In USA, a model has been prepared to generate the conditions of the Big Bang theory. The scientists of Berkeley University have used helium balloons to study the microwave radiation and have supported the Big Bang hypothesis. Experiment is being carried out by more than 5,000 Scientists at European Organization for Nuclear Research, CERN in Geneva. These scientists are busy in carrying out research work to generate the condition of huge explosion. 1.4.3.3 Cepheid hypothesis of A.C. Banerjee. On seeing the star named Delta Cephei, Banerjee was inspired to postulate his theory about the origin of solar system in the year 1942. According to him, some stars in the universe keep contracting and expanding. This process is called pulsation of stars, and the stars undergoing this process are called Cepheid variable. The group of stars in the universe also contains such stars. The brightness of these stars continuously keep changing. Such systematic change in the light of these stars is the result of the process of contraction and expansion. Once an intruding star happened to pass closer to such Cepheid star, the pulsation in the Cepheid star increased due to the gravitational attraction of the intruding star. As a result, the intruding star attracted enormous amount of the matter of the Cepheid star towards itself. The condensation of this matter forced the planets. The residual part became the sun. The planet started revolving around the sun. The intruding star had by then moved far away on its path. Besides these theories, there are some more theories which have been recently postulated. Among them, a few significant ones are listed below. Rosgun's rotational and tidal hypothesis. Kuiper's hypothesis, 1949. Fosenkoff's globule concept. Voigtkicher's protoplanetary chondrules concept, 1971. Jupiter-Sun binary system hypothesis of A. M. Drobyshevsky, 1.5 Summary. Thus, in this unit, you have learned the following concepts and key themes. Regarding origin of the Earth in totality. Our solar system consists of a star of average size and luminosity, known as the Sun, and the planets, their satellites, numerous comets, asteroids, meteoroids, and the interplanetary medium etc. The planets, most of the satellites, and the asteroids revolve around the Sun in the same direction, counterclockwise, in nearly circular orbits. Ellipses but close to circles. When we look down from above the Sun's north pole, the planets seem to be orbiting in a counterclockwise direction. You have learned that a new class of dwarf planets was added in 2006. Such planets are confined mostly in the asteroid belt and the Kuiper belt as well. Furthermore, the planets orbit the Sun in or near the same plane called the ecliptic. Scientists same time calls Pluto as a special dwarf planet in that, and its orbit is the most highly inclined, 18 degrees, and the most highly elliptical of all the planets. The Sun contains 99.85% of all the matter in the solar system. You have also learned that the planets which condensed out of the same disk of material that formed the Sun contain only 0.13% of the mass of the solar system. Jupiter contains more than twice the matter of all the other planets combined. The four primary terrestrial worlds are the innermost planets in the solar system. These are Mercury, Venus, Earth, and Mars. There is an additional 8 other terrestrial worlds: the Moon, Io, Europa, Ganymede, Callisto, the 4 Galilean moons, Titan, a moon of Saturn, Triton, a moon of Neptune, and Pluto. They are called terrestrial because they have a compact, rocky surface like the Earth's and are spherical in shape. The other moons are not spherical and are more asteroid-like, i.e. irregular. Venus, Earth, Mars, and Titan have significant atmospheres. The rest have little to zero. Jupiter, Saturn, Uranus, and Neptune are known as the Jovian, Jupiter-like planets because they are all similar in size and structure, i.e. gigantic compared with Earth and having a non-solid, gaseous nature. The Jovian planets are also referred to as the gas giants, although all of them might have small semi-solid cores below their thick atmospheres. A planet revolves around the Sun. A moon or satellite revolves around a planet. The term planet or moon is not selected by mass or size of the body. For example, Titan, a moon of Saturn, is bigger than Mercury.